Welcome to LabVIEW assignment number 2. In this assignment, we were asked to utilize SubVIs. In this case, we will be using one SubVI in our main program, which is our main VI, and we will use two instances of it. To start with, let's look at our SubVI to our left. On the front panel, you can see clearly that there are inputs and outputs that the user can input and then receive the outputs for the mean using a toggle, which is utilizing an Enum between 0 and 1, which switches between a mean calculation and a RMS calculation. If you run this and change the numbers here, you will see that it will calculate first the mean with operation 0 here as a user can select. And then I use a string so that the user can know what mode they've selected, even though it does state right here in the key what each mode will do. So if you run this, you see that the solution, which is the mean or central tendency, comes to 10.61. Now, if the user decides that they want the RMS value, then they can simply switch the toggle to 1, and then run the program, and then that will give them the RMS value. Now, if we look inside our block diagram, you can see that there is user selection using the enum and 3 inputs, x1, x2, and x3, and then using arithmetic blocks from LabVIEW, we can conduct the operations either to conduct the mean or the RMS value. The mean is the default, and the RMS value is the other operation within the case structure. And this is this mode is utilizing a string. Now, moving on to our before we move on to the main VI, I wanted to show you one more thing, which will go back to the front panel. And if you look at the connector pane right here, this allows you to select and map the inputs and outputs within the connector pane to the front panel user selection modes. The toggle and the inputs right here are mapped in the connector pane, and this icon, that's going to be used in our main main VI, was created using a graphical program and then scaled so that it would fit within LabVIEW. Now looking at our main VI, which utilizes utilizes our SubVI, we will first look at the block diagram, and then we will go back to this front panel here that I have on the right side of the screen. Now, looking within here, within the block diagram, within the main VI, you can see that there are 2 instances of the SubVI. I utilized simple arithmetic to calculate the functions that are to the right of this while loop. The reason why I used a while loop is so that with each iteration, it would run through this and then plot a point within these graphical waveform generators within our while loop. And I changed the iteration speed in which each point is plotted utilizing a delay block. Now moving back to our front panel for our main VI, this right here where it says where it says while loop control, this allows the user to select the speed at which the points are plotted within our graphs. Once again, I provided the functions so that the user would be able to know what internally the VI is actually doing and what mathematics are linked with each function block within the block diagram. So turning this on, we're going to start off with a 50 millisecond between each plotted point. And as you can see, this plots the points here on our right. And if you actually look, you can actually see what's happening in the SubVI to our left. As you can see, as it cycles, it's moving the data through the three different points. The three different points are being plotted, and it is actually calculating the instantaneous mean in our SubVI. We can also switch this to our different mode, but we have to first stop the program in order to switch it if we want to see an instantaneous mapping to our SubVI. This is something that most people may or may not do, but it's another way of testing your overall programs, including the SubVIs, to make sure everything's working properly. So if we go back here again and we run this, you're going to see that it's now conducting the mean instead of the RMS value into our SubVI, and then it is coming back and going on these graphs here. And now there's one other thing that I wanted to show you, is that also you can hit stop here using this, which I switched it to a push to stop. If you look in here in mechanical action, you can have switch when pressed or latch when released. And I changed this one to switch when pressed so it would work better for us. And then you don't have to go and exit the whole program and then restart it in case there's some problem with it not running. Now we're going to change this to, say we want to type in and we want to run it at 300, say, milliseconds. You're going to notice that it runs a lot slower, which is, if you're trying to look at stuff, you can look in your SubVI and see that the values are being passed in slower, so you can go and see what the points are, how the points are being plotted, and the mean and RMS values are likewise plotted at the same time. The reason I selected 10 and 500 is outside this range. The speed in which, if it's really slow or really fast, it doesn't really add any usable information after that range. Plus, allowing the user to put in any type of speed that they want the data to run can also tax the machine that the VI is being run on, and or leads to potential program crashes. I also changed all the colors so that they would be distinct and put them on the white background as the assignment asked. And that pretty much sums up this assignment. I hope you enjoyed another LabVIEW exercise, and hope you learned something else from this one. And I'll see you again on the next one. Goodbye and enjoy.